This video is on exponential application, so basically meaning word problems. So we're going to start with our favorite formula that we've worked with so far. Y equals A times B to the X power. Y is the ending value. A is the initial value or your starting amount. B is the growth or decay value. How much is it growing by, percentage-wise? Is it doubling, tripling, all kinds of stuff. So next to it, it says if blank, change blank. So remember, if we're given a percent, we have to change it to a decimal. Always. And X is our time. So I have two examples on the next slide that go over this. So the first one we have, we're buying an Xbox One for $390. Okay, this gaming system depreciates in value. Depreciates, that's decay. Oh, I can't spell decay. Decay. Okay, they're only worth 80% of their value, which means they depreciate by 20% each year. So it's only worth 80%. How much will it be worth in 5 years? So our starting amount, 390. Our growth or decay value is 80%. Again, that 80%, we take the decimal 1, 2, so it's 0.8. And it's decaying, so yes, it should be less than 1. Okay, our exponent, our time, is 5 years. So we have y equals 390 times 0.8 to the 5th power as an exponent. Most of your calculators, you need to take care of that exponent part first. So 0.8, x to the y, y to the x, or caret to the 5th power. You should get a nice pretty decimal. You multiply it by 390. And after 5 years, it should only be worth, we're talking money, so 2 decimals, $127.80. It was $7.95. That 5 made it turn into an 80. Okay, looking at example 2, we have some bacteria. I'm not going to try to pronounce that word. That looks fun. But we have some bacteria. Okay, we're starting with 150. It doubles every hour. Predict how many are the number of bacteria after 12 hours. So we start with 150. It's doubling, which means times 2. We don't necessarily have to worry about changing that to a decimal because it's not a percent. Our time is 12 years. Excuse me. So we plug it in. Y equals 150 times 2 to the 12th power. Again, take care of that exponent first. 2 to the 12th power, you should get 4,096. You multiply that times 150. So after 12 hours, not years, I keep saying years, I'm sorry. After 12 hours, you should have 614,400 bacteria. It's not too bad. Okay. Now, we do have another formula. This is when we're talking about compound interest that is not compounded continuously. Remember, when it's continuously, that's where we use the A equals P times E to the RT power. But we have a new formula. It is going to be A equals the principal times 1 plus R over N to the n times t power. A is the ending value. P is the starting amount. R is the interest rate. Remember, percent to decimal. Always. N is the number of times in a year. So I have some key words. If it says quarterly, how many times does that happen a year? 4 times. If it says monthly, that happens 12 times. Semi-annually happens 2 times a year. We also have weekly. Oops, can't spell. Weekly. That happens 52 times a year. I think that's all I got. Time is in years. Time in years. So this has to be in years. So I have 2 examples for us on this one. If at any time you need to pause to write, please pause to write. So you deposited $1,000 into a bank that pays 5% annual interest compounded quarterly. What is the balance after 6 years? So how much are we starting with? We're starting with $1,000. We get that right there. What is our interest rate? Our interest rate is 5%. Change it to a decimal, 0.05. And how many times a year is it happening? Quarterly, that's 4. And time after how many years? 6. Now it's plugging and chugging. So A equals 1,000 times 1 plus the rate, 0.05, divided by how many times it happens a year? 4 times 6. Oh, that's not a 6. So you type that all in your calculator. You should know how to use your calculator by now. When you do this, let's see how much we get. Let me type it into my calculator. You should get about, rounding to 2 decimal places because it's money, $1,347.35. Okay, marked out part of this second equation or question. Oh, I did it again. So, moving on to example 4. You deposited $400 into a bank account that pays 10% interest compounded monthly. What is the balance after 7 years? So we start with $400. It pays at a rate of 10%. Okay, as a decimal, that's 0.1. Oh, that's messy. I'm sorry. 0.1. How many times a year does it have? Monthly, that's 12. And after 7 years for our time, plug and chug. 1 plus 0.1 divided by the 12 times it happens a year, exponent 12 times 7. Type it into your handy dandy calculator. Again, you should know how to use your calculator. When you do that, after 7 whole years, you should have a total of $803.17, again rounding to 2 decimal places. So these are the other 2 formulas you need. So you now have 3 total formulas for exponential growth, exponential decay. We have A equals P times ERT. So I'm going to go ahead and write them on this second page. A equals basically PERT. That's for compounding continuously. We had exponential growth and decay, A times B to the X. And then we have the one that we just learned. That looks like this. Oh, that's an N. That's an R on top. Okay, and that's when it's compounded with different amounts. So these are our top 3 formulas that you need. You will be provided with these formulas on any assessment, so just keep that in mind.